Hello, good evening, everyone. So, I hope my voice is clear. Just let me know if the voice, yes. So, audio is absolutely fine. And let's check about the video. Yes, good evening, Vishnu. Thank you so much for your compliment. Thank you so much, dear. So, please let me know that which topic of analog communication you are not comfortable with. Let me know which is the topic which you want to revise, or if you want to clear any concept from the analog communication, then we will discuss that part only. Yes, Vishnu, tell me guys which topic you want to study in the analog communication. Which topic you want to study? Angle modulation. Okay, one, I have got one comment that is angle modulation. Yes, good evening, dreamer. So let's connect with all of you. Please share the video as much as possible. Then we will start our session with the brief introduction about myself and the different series that we are going live with. So this is Saket Verma. I am having more than 12-year experience in the field of teaching, and I have done MTech from IIT Guwahati and cleared different PSU exam as well. And if I talk about the subjects I teach is electromagnetic theory, communication system, advanced communication system, signal system, and ICT. So most of you are saying angle modulation or the frequency modulation. So which, what is your weak point in the angle modulation? Because you know we are having only 5 to 6 lectures in the Gate AIMER'S crash course. So I will be focusing only on the topic which you are facing the difficulty, so that we can have the better utilization of these 5 lectures. Because if I teach randomly any particular topic, like suppose I teach Armstrong method, if suppose I teach time domain representation of amplitude modulation, it will be of no use. Yes, good evening, Vishal. Random process, Dreamer, random process we will cover in the day after tomorrow. This is not the part of analog communication. As I told you, that we are having the Gate Aimer series that has been started from the 14th of November. So we will be having the 5 lectures from Monday to Friday. Okay, so Monday to Friday we are having 5 lectures in this particular Gate Aimer series. Okay, Monday to Friday, every day 4 p.m. and we will be discussing 5 chapters. Okay, and what are those 5 chapters? So that is your analog communication, as I have already just said. This is analog communication first, and second we will take a random variable. Third we will take random process. Fourth we will take digital communication, and fifth I will take information theory. So just tell me which topic of analog communication you want me to cover today. This is for the today session. Okay, tomorrow we will be discussing about the random variable. Day after tomorrow we will be discussing about the random process. Then on Thursday digital communication, and then Friday and Saturday, or maybe Friday or Saturday, information theory. Yes, Sham Babu, thank you so much. Thank you so much. So now tell me, Dreamer, which topic of analog communication you want to revise or you want me to teach here? So now you should also know that there is a complete roadmap to get the All India rank under 100 in GATE 2024, and that particular session is going to take by the Joshit sir in live on the 20th December 8 p.m. And there is a GATE PYQ series we are going to start, and it has been already started actually. So where we are going to cover the 5-year question paper from the EEC and IN, and that is been started from Sunday itself. So don't forget to subscribe. BJT amplifier, obviously, Varun, I am not going to teach you the analog electronics here. I am here to teach you the communication. And there is a All India Open Mega Mock Test in the for the GATE 2023. So just don't forget to register yourself in the All India Mega Mock Test. And the solution of the each question will be provided by the expert faculties in the BYJU'S exam prep app, and this is from the 13th December to 20th December, which is from for tomorrow, up to tomorrow. So angle modulation, you are all are expecting. There is a GATE and ECE test series also running. So everything is given in the description. So whatever is required, everything is given in the description. So just go and check the description also. Okay. Let's start the session with the angle modulation. Okay, so most of you want me to cover angle modulation, so let's take angle modulation as a today's topic. Okay, so angle modulation. Okay, so angle modulation, what is the angle modulation? Basically, we know that whenever we want to change the angle of any carrier signal, and the carrier signal is defined as AC cos of omega ct plus phi. Here we say that this omega ct plus phi is the angle of the signal. Okay, here we say this is nothing but the angle of the carrier. Okay, this is we called as angle of carrier. So what is the definition of the analog angle modulation? When the angle of the carrier signal changes according to the message signal. Okay, the angle of when angle of carrier varies according to the instantaneous value. Okay, according to instantaneous value of message signal. Instantaneous value of message signal. Okay, instantaneous value of message signal, right? So what is angle here? As I said, the angle is theta, and theta is omega ct plus phi, right? Now there are certain parameter which is related to the angle modulation. The first parameter is called the instantaneous frequency. So how do we calculate the instantaneous frequency? So to calculate the instantaneous frequency, instantaneous frequency is given by omega I is equal to d theta by dt. So remember that for any particular signal you can calculate the instantaneous frequency just by differentiating the angle of that particular signal. Okay, if the signal is written in this form, then you can easily tell its instantaneous frequency. So when we will differentiate, we get omega c plus d phi by dt. Okay, plus d phi by dt, right? Now, because this will give you the instantaneous frequency in the radian per second, so this will give you the result in radian per second, and mostly we want to calculate the instantaneous frequency in hertz. So for this we will have to divide it by 2 pi. So when you will divide it by 2 pi, so this is 2 pi fc divided by 2 pi divided by 2 pi plus 1 upon 2 pi d phi upon dt. Okay, so this 2 pi and 2 pi will get cancelled, and you will get the instantaneous frequency as fc plus 1 upon 2 pi d phi by dt. So for any signal, if they will ask you to calculate instantaneous frequency, whether it is a frequency modulated signal or it is a phase modulated signal, you can calculate it by just using this formula. Okay, is this part clear? that if you want to calculate the instantaneous frequency for any signal, you can calculate its instantaneous frequency by just differentiating with respect to t, and then you can divide it by 2 pi and you will get the instantaneous frequency. Come on, tell me, is it okay? Is it okay? Vishnu, Kiran, Dreamer, Shyam Babu? Yes. Okay, so this is the first part, and which is very important parameter in angle modulation. Now coming to the next part, which is very important, and this is known as frequency deviation. Okay, this is known as frequency deviation, right? What is frequency deviation? Frequency deviation is defined as deviation around the carrier frequency. Deviation around carrier frequency is known as frequency deviation. Okay, so what is the deviation around the carrier frequency? The deviation around the carrier frequency means you have calculated the instantaneous frequency, which you have written as Fc plus 1 upon 2 pi d phi by dt. Just try to understand it step by step, then you will never get confused, and if suppose you get confused, you can derive it very quickly. So you have calculated the instantaneous frequency. Now if I subtract the instantaneous frequency with the carrier frequency, we get the frequency deviation. So frequency deviation is nothing but the deviation around the carrier frequency. The carrier frequency is Fc, and if you change the frequency around the carrier frequency, you get the frequency deviation, which is 1 upon 2 pi d phi upon dt. So this will be our formula to calculate the frequency deviation. Okay. So this will be our formula to calculate the frequency deviation. It is saying that if suppose you are having the carrier frequency, and if you change the frequency either in the left hand side or in the right hand side about this carrier frequency, suppose you change the frequency and you go up to suppose maximum value of the instantaneous frequency, and if you go suppose minimum value of the instantaneous frequency, so you are changing the frequency around the carrier frequency. In this change is nothing but the frequency deviation. Okay, this change is nothing but the frequency deviation. The deviation around the carrier frequency. There is a change around the carrier frequency, and the value by which you are changing the carrier frequency is nothing but a frequency deviation. So this is very important formula. Now, depending upon the value, we have the maximum frequency deviation. Okay, depending upon the value of phi. So, how do you calculate the maximum frequency deviation? So, first of all, you have to, calculate the d phi by dt, and then take the magnitude, and after taking the magnitude, calculate its maximum value. So, this is very important. Okay, how do you calculate the maximum value of the frequency deviation is always very important. First of all, you have to differentiate the value of phi and then take the magnitude and then calculate its maximum value. For example, okay, for example, how do you calculate the maximum frequency deviation? This is the point where the most of the students gets confused, that how do we calculate the maximum frequency deviation. So the message signal is suppose AM, not take message signal, let's take phi. Let's take phi. Let's take the phi is equal to AM cos omega mt. Okay, suppose I take phi is equal to AM cos omega mt, and then maximum frequency deviation if I want to calculate, then this will be 1 upon 2 pi and differentiate this phi. So d upon dt of am cos omega mt. Then before differentiate, before taking the maximum value, I will take magnitude. So when I will differentiate, I will get minus am omega m and then sine omega mt and magnitude, and then its maximum value. So when I take the magnitude, it will become am into omega m and then sine omega mt divided by 2 pi, and then we will calculate, after taking the magnitude we will calculate the maximum value, and when we calculate the maximum value we will get am, and omega m can be written as 2 pi fm, so we will get am into fm. Okay, so this is the point where the most of the students get confused, that when to take the maximum value and when to take the mod. So first of all you have to calculate its magnitude and then calculate its maximum value. Okay, is it clear? Is it clear? Yes. So first of all you have to calculate its magnitude and then you have to calculate its maximum value. And this will be useful when there is a slope also. Like this can be very much useful when you are having the two different type of slope like this. Okay, suppose you are having these two different type of slopes. Okay, in the value of 5, suppose this is having the slope. Okay, this is having the slope plus 5 and this one is having the slope, suppose minus 10. Okay, so this is having the slope plus 5 and this is having the slope minus 10, and when we want to calculate the frequency deviation, and this is nothing but a 1 upon 2 pi d phi by dt. So d phi by dt is nothing but the slope, right? D phi by dt is nothing but the slope. So here how do you calculate? So this is 1 upon 2 pi. We usually take the maximum value. Suppose you take the maximum value of the frequency deviation, this is slope plus 5 and this is slope minus 10, then obviously if I ask you to calculate the maximum value, then the maximum value is plus 5, so you will take plus 5, and the maximum frequency deviation you will say, sir, it is 5 upon 2 pi. And one can calculate the maximum frequency deviation like this also, 1 upon 2 pi. He will calculate the magnitude of minus 10 first, and then he will calculate its maximum value. So when we will calculate its magnitude, it will be 10 upon 2 pi. So the answer will be 5 upon pi. So which one you will say correct? Which one you will say correct? Which one is correct? First one or the second one? Which one is correct? Which one is correct? First one or second one? Which one is correct? Yes, this one is correct. Okay, this is correct and this will be wrong. Okay, this will be correct and this one will be wrong. So this is correct. Okay, and this is wrong. So this is the use of the maximum frequency deviation. How do you calculate the maximum frequency deviation is very important, because most of the students gets confused here. Yes. Now let's calculate the third important term, which is a maximum phase deviation. Okay, maximum phase deviation, which is the third parameter. So maximum phase deviation, how do you calculate the maximum phase deviation? It is nothing but the difference between phase of difference between phase of modulated carrier and unmodulated carrier. Okay, it is nothing but the difference between phase of modulated carrier and unmodulated carrier. So basically, suppose you are having the carrier signal. This is a pure carrier signal, unmodulated carrier signal. This is your AC cos omega CT. Okay, this is your unmodulated carrier signal, and this is your modulated carrier signal. Suppose this is AC cos of omega CT plus phi plus theta. Okay, phi plus theta. Now, how do you say what will be the maximum phase deviation or phase deviation? Can anybody tell? What is the phase deviation in this case? What is the phase deviation in this case? Can anybody tell? Phase deviation. It is denoted by delta phi. Can anybody tell what is the phase deviation here? Come on, tell me what is the phase deviation here? What is the phase deviation here? I have written the definition. So read the definition and tell me what should be the value of phase deviation. What should be the value of phase deviation? Come on. So according to the definition, difference between the phase of modulated and unmodulated. So the modulated carrier here is, okay, this is your unmodulated carrier. Okay, this is unmodulated carrier and this is your modulated carrier S of t. So the difference between the phase is phi plus theta and the phase of the carrier is 0. So the phase deviation is nothing but a phi plus theta. The phase deviation is phi plus theta, and if you want to calculate its maximum value, okay, if you want to calculate its maximum value, then this is del phi max is equal to theta plus phi. Okay, this is nothing but a theta plus phi, right? So we have got the three parameter. First parameter we have calculated as instantaneous frequency. Okay, the second parameter we calculated instantaneous frequency. First well parameter fc plus 1 upon 2 pi d phi by dt. Second parameter we have calculated as frequency deviation, okay, which is delta f is nothing but fc plus, sorry, fi minus fc, which is 1 upon 2 pi d phi upon dt. And third we calculated as phase deviation, delta phi as phi minus theta, phi plus theta minus 0. Okay, is it okay? So those who want to, discuss this part, those who are having the doubt in the angle modulation, now can you tell me, is it clear up to this part? Up to this part it is clear? Come on guys, tell me quickly. So these are the three definition, and in these three definition you will see one question in the GATE examination for sure. And in fact, in the many test series that you are now appearing, you are having maximum question of analog communication, especially in the angle modulation from these three topics: instantaneous frequency, frequency deviation, and phase deviation, modulation index. All these are favorite topic of any GATE examination. Any year, if you will see the maximum questions from these three topics. Okay, now coming to the phase modulation. What is the phase modulation? The phase modulation says phase of the carrier should vary according to instantaneous value of modulating signal. Okay, instantaneous value of modulating signal, right? So this is the phase modulation definition, and according to the definition, the phase is phi. So this phi should be proportional to your message signal. Okay, phi should be proportional to your message signal. Then we will say that this is a phase modulated signal. So phi should be proportional to your message signal, right? Now, if phi is proportional to message signal, then what will be the value of phi? Phi is equal to, okay, the value of phi is equal to proportionality constant. We will use Kp into mt here. Proportionality constant is Kp, which is known as the phase sensitivity of modulator. Okay, phase sensitivity of modulator, and the unit of this is phi upon k, phi upon mt. Phi is having the unit radian, and message signal can be volt. So radian per volt is the unit of kp. Okay, now what is the expression? So the expression of pm, expression of phase modulated signal, expression of phase modulated signal. Okay, what is the expression of phase modulated signal? So this will be S of t is AC cos of omega ct plus, here instead of having phi, now we will have kp into mt. So this is the expression. Okay, so this is the expression AC cos of omega ct plus kp into mt. Is it clear to everybody? Quickly tell me, is it clear to everybody? Now, do you have any doubt up to this part? Do you have any doubt, guys? Come on. Tell me, do you have any doubt? Do you have any doubt up to this part? Okay. Now, what is our aim? Next, our aim is to calculate the different parameters that we have calculated. The three parameters we have calculated is instantaneous frequency, frequency deviation, and the phase deviation. Okay, so now we want to calculate these three things for this particular phase modulated signal. So for the phase modulated signal, the first parameter which we want to calculate is instantaneous frequency. So according to the general equation, this instantaneous frequency is Fi is equal to Fc plus 1 upon 2 pi d phi upon dt, right? So what you have to do, if you want to calculate the instantaneous frequency for the phase modulated signal, okay, if you want to calculate the instantaneous frequency for the phase modulated signal, what should be expression? Fc plus kp upon 2 pi dmt upon dt. Okay, dmt upon dt. Now this dmt upon dt is nothing but the slope of your message signal. Okay, this is nothing but the dmt upon dt is slope of message signal. Okay, slope of your message signal. Now, how do you maximize the instantaneous frequency? Dreamer, can you tell me how do you maximize the instantaneous frequency? How do you maximize the instantaneous frequency here? Maximum instantaneous frequency. Maximum instantaneous frequency. So the maximum instantaneous frequency in case of PM you will get when you have the maximum value of slope. Maximum value of slope. Okay, maximum value of slope. And how do you get the minimum instantaneous frequency? So minimum instantaneous frequency, yes, minimum instantaneous frequency is Fi minimum is Fc plus Kp upon 2 pi minimum value of dmt upon dt. Okay, so now we have seen that here we are having the two different values. Somewhere we are getting maximum, sometimes we are getting minimum. Now it depends on the maximum and the minimum value of slope. So now in this case, how do we take the maximum and the minimum value of the slope? Now the example is here. Okay, now the example is here. If you want to calculate the maximum value of instantaneous frequency, then you have to take the positive slope, and if you want to calculate the minimum instantaneous frequency, then you have to take the minimum slope. Here we will not take magnitude, because to maximize the frequency, then the carrier frequency, we have to add something. You can see that when this fc plus something is there, fc plus, when you will add something, then the instantaneous frequency will be greater than the carrier frequency, and when we will subtract something with the carrier frequency, then the frequency will be less than carrier frequency. That will give you the minimum instantaneous frequency. So here you can see that in the formula I have not written the magnitude. Okay, I have not written the magnitude. I have written in that not written in the magnitude. I have written in the bracket. Okay, this is not a magnitude. Remember that this is not a magnitude. Here you have to select the value of the slope, positive as well as negative, according to what you want to calculate. If you want to calculate the maximum instantaneous frequency, then you have to add, that means you have to take something positive, and when you want to calculate the minimum instantaneous frequency, then you have to take something which is giving you negative value, that is fc minus something. Okay, one video on the receiver and detectors like map and ML. Right now I am traveling, will watch events. Okay. Yes, Nachiket, definitely we will take this as our last lecture, that is information theory. So we will take the live session on the map and ML receiver and detector in the noise in digital communication. Okay. So this is how we calculate the maximum and the minimum instantaneous frequency. Slope is given, and then according to the slope, positive or negative slope, we can calculate the instantaneous frequency. Very popular example you will see here in many textbook also, and in the many different test series also. There is a very popular question where you have this type of message signal. Okay, this is very popular question. So this is our message signal, and suppose you want to calculate the slope, then this is you giving you positive slope, okay, and this one will give you the minimum slope or negative slope. Okay, so this is negative slope, it is negative, and it is giving you the positive slope. So when it is positive, when you will take the positive slope, it will give you the maximum instantaneous frequency, maximum fi, and when you take the negative slope, it will give you the minimum instantaneous frequency, that is minimum fi. Okay. Okay, if this is the message signal given to you in the question, then when you take the positive slope, it will give you the maximum instantaneous frequency. When you will take the negative slope, you will get the minimum instantaneous frequency. So this will be the value of maximum and minimum instantaneous frequency. Now if I want to calculate the frequency deviation. So frequency deviation is nothing but a kp upon 2 pi and dmt upon dt. Okay, this is the formula. Now if I want to calculate its maximum frequency deviation, so maximum frequency deviation will be calculated as kp upon 2 pi. First of all, you have to take the mod, so mod of dmt upon dt. Okay, mod of dmt upon dt, and then its maximum value. Okay, so maximum value of dmt upon dt. So the procedure is same for the frequency deviation. And the phase deviation, minimum, actually we don't calculate the minimum frequency deviation. Okay, remember we always calculate only and only peak frequency deviation. Okay, we always calculate the peak frequency deviation, we never calculate minimum frequency deviation, because there is no significance of minimum frequency deviation. We always calculate peak frequency deviation, so that is why, remember this. Now coming to the third point. Okay, so the 2 points we have calculated, frequency deviation and the instantaneous frequency. Now what is the phase deviation? What is the phase deviation? What are the topics to learn preparing communication? Will I start now? If you want to start now, then you can learn the analog communication completely, because analog communication is easy and you can cover it very quickly. So at least you can cover the analog communication. Okay, and if you are giving 15 days of time, then you can complete the analog communication as well as in the digital communication, cover the PCM part. Okay, the PCM you should cover, that is your baseband transmission, or simply digital communication first chapter, which is your sampling, quantization and encoding, which is known as PCM. So phase deviation, what is the phase deviation? So the phase deviation is the difference in the phase. So phase is nothing but a Kp into Mt. Okay, Kp into Mt. Only read these three chapters, Raja. First chapter, as I told you, analog communication, in which amplitude modulation is the first chapter. Second chapter is your angle modulation, and also cover the superattitude and receiver. That will come in these two chapters itself, you can say. And the third chapter that you have to cover is PCM, that is sampling, quantization, and encoding. So these three chapters you can cover in the next 15 days, and you can have the almost 50 to 60% marks if you prepare these three chapters very well. Okay. So this is Kp into Mt, which is the phase deviation in case of phase modulation. Now, what if I take the message signal as Am cos omega mt, Am cos omega mt, then instantaneous frequency, no need of calculation of instantaneous frequency. Let's calculate the frequency deviation. Frequency deviation is Kp upon 2 pi dmt upon dt. So d by dt of Am cos omega mt, and when we calculate it, it will be minus Kp upon 2 pi Am into omega m into sine omega mt. And when we want to calculate the maximum value, then what we have to do, we have to take the magnitude. Okay, magnitude, this is minus Kp upon 2 pi Am into omega m sine omega mt, and then its maximum value. So when I take magnitude, I will get this plus sign instead of minus sign, and then when I take the maximum value, the maximum value of sine is always 1, so we will get Kp Am into Fm. So very important conclusion came here is that the frequency deviation depends on, okay, the frequency deviation depends on amplitude and frequency of message signal. Amplitude and frequency of message signal. Okay, very important conclusion came here is it depends on both amplitude and frequency of your message signal. Okay, so what is the modulation index? The modulation index is defined as the fourth parameter about the phase modulation we are calculating. First, we calculated the instantaneous frequency. Second, we calculated the frequency deviation. Third, we calculated the phase deviation. And now we are calculating the modulation index. So, modulation index beta is maximum frequency deviation divided by message signal frequency. This is the definition. Okay, this is the formula of modulation index. Now, if I apply it for the single tone sinusoidal modulating signal, okay, that is for single tone sinusoidal modulating signal for single tone sinusoid modulating signal, that is MT is equal to AM cos omega mt. Okay, if I take AM cos omega mt, then what is the frequency deviation? The frequency deviation we have calculated as kp into AM into FM, and we have to divide it by the message signal frequency, which is FM, and when we divide it, it will be cancelled and we get kp into AM. So kp into AM is nothing but your modulation index. Yes. Yes, Chinmay. So Kp into Am is your modulation index. Okay. Now, what is the value of phase deviation? What will be the value of phase deviation? Phase deviation for single tone, phase deviation of Pm for single tone. So this is delta phi is equal to, we have calculated as Kp into Am, right? And it is nothing but a beta here. You can see phase deviation we have calculated as Kp into Mt, and we want to calculate the maximum value of the phase deviation. So the maximum value of phase deviation is maximum value of the message signal, and maximum value of message signal is Am. So Kp into Am, that is equal to beta. So this is your phase deviation. Is it clear up to this point? Rajashika, actually it is, I will say not, this lectures will not be sufficient, because in the 5 lectures you will not learn maximum of communication. So I will suggest you, if you want to learn the communication, then you have to follow the complete crash course which is going in our app. So you just register yourself in our app. There is a rank booster series, and that rank booster series will have the number of lectures in the communication, and from there you can learn the important topics of communication for the gate 2023. Okay, I am here to revise something which you find the difficulty, here you will not understand from the basic, because if you are reading the selective topic, then you should clear with the basics, and I am here assuming that you know some basics of the communication, and then I am telling the important topic. Like in the today's lecture, if you have any idea about the angle modulation, just basic idea, then if you follow the lecture from the beginning, then you will understand how to calculate the values, how to find the different parameters, and then you apply this concept in the questions, because here also we are not solving the questions. Now let's come into the phase frequency modulation. Okay, after the phase modulation we have the frequency modulation. So Dreamer, do you have any doubt in the phase modulation? Do you have any doubt in the phase modulation? So the modulation says that the frequency deviation should be proportional to the message signal. So this is our definition of the frequency modulation. No, good. Okay. Uh, round tube, as I asked you in the beginning itself, that do you have any problem in analog communication? The topic where you find the difficulty, because in the 1 and 2 hours we will not be able to complete the theory and the questions. I am just taking your doubts, and I will explain that particular thing in the lecture, so that that particular doubt will be clear in the single lecture. So like in the beginning of this lecture, I asked you what are the topics of the analog communication you find the difficulty. So many of you have said that angle modulation. So that is why we started discussing the angle modulation. So if you have any doubt in any other topic, you can tell me. We will discuss that tomorrow. So delta F is proportional to MT. Okay, delta F is proportional to MT. So this delta F is equal to Kf into MT. We will write. Okay, and because we want to write the expression, what is the frequency deviation in general? The frequency deviation in general is written as 1 upon 2 pi d phi by dt. Okay, round tube actually, yeah, we will do that. Okay, we will do that. Don't worry. Just you follow this lecture from the beginning. You will understand very clearly what I am telling. Okay, so from here we can calculate the value of phi, and this is 2 pi kf integration from minus infinity to t m lambda d lambda. This is the value of phi. So what is the expression? The expression of Fm is, yeah, actually, we are having separate series for the questions. Like the previous year gate questions we are running, and we have also solved some questions. You might have seen that the session name is Dhamakedar Questions of Communication. So those lectures you will follow, and after this lecture, just go to that particular session. That will there it will be there in my playlist, and when you will go and you will see that there will be a question. So after reading this topic, you when you go into that lecture, you will be able to solve the problem also. Expression of Fm. So what is the expression of Fm? Expression of Fm is S of t is equal to AC cos omega ct plus phi. What is phi? Phi is 2 pi kf integration minus infinity to t m lambda d lambda. Okay, so have you got this? Remember that here the value of Kf, which is the phase sensitivity, Kf is your phase sensitivity, and sorry, this is the frequency sensitivity of modulator, and its unit is hertz per volt. Okay, so when you write this formula 2 pi, that kf is in hertz per volt. Suppose this kf is defined as radian per volt. Okay, suppose this kf is defined in radian per volt, then this 2 pi will not come. Okay, this 2 pi will not come if the kf is defined in radian per volt. Let me write here. So this S of t is sometimes defined as AC cos of omega ct plus kf. Directly they write kf minus infinity to t m lambda d lambda, like this. So this kf is defined in radian per volt per second. They will write like this also. Radian per volt second. Sometimes here hertz per volt second, like this. Okay, hertz per volt second, because of the unit. Sometimes they will say radian per volt only, and sometimes they say radian per volt second. So both are correct. Both are correct. Okay, now is it clear up to this point? Now, what is the instantaneous frequency? If you want to define instantaneous frequency, Fi is Fc plus. Okay, Fi is Fc plus 1 upon 2 pi d phi by dt. So here you can see that this is 1 upon 2 pi, okay, and d upon dt of phi. So what is the value of phi? The value of phi is integration from minus infinity to t and m lambda d lambda. Okay, from here you will calculate the instantaneous frequency. What is the frequency deviation? The frequency deviation here is Fi minus Fc. Okay, Fi minus Fc, and this is nothing but a Kf into Mt. Okay, so again, when you calculate the maximum frequency deviation, you have to just take the Kf, then the magnitude of message signal, and its maximum value. Magnitude of message signal, okay, don't forget, in case of frequency deviation we always take the magnitude first and then we calculate its maximum value. Magnitude of message signal. And what is the value of the, okay, we have one more slide. Yeah. What is the value of the phase deviation here? Phase deviation. Phase deviation is delta phi is equal to the difference of the phase of the modulated signal. So what is the phase of the modulated signal? The phase of the modulated signal is minus infinity to t m lambda d lambda. Okay, this is the phase of the FM signal, and you can calculate its maximum value like this. Okay, now suppose if I ask you for the single tone sinusoidal for message signal is equal to Am cos omega mt, then here also it is minus Am into omega m, then yeah, here we have to integrate it, right? So here we have to integrate it, so it will be plus, so Am omega m sine omega mt. So the maximum frequency deviation will be Am into omega m. Okay, Am into omega m will be the maximum value. This is maximum phase deviation. Maximum phase deviation. Okay, and now let's talk about the modulation index. So modulation index of FM. Modulation index of FM. The basic definition is same. That is, it is nothing but the ratio of maximum frequency deviation divided by FM. Maximum frequency deviation divided by FM. So what is the frequency deviation for the single tone modulation, or simply in general? So this is Kf into maximum value of message signal. Okay, let's write like this. Kf into MT. Okay, this is Kf into Mt, and for single tone modulation this is Kf into Am and then cos omega Mt. What is the maximum value? So the maximum value will be Kf into Am. Okay, now what is the modulation index? The modulation index is beta maximum frequency deviation divided by message signal frequency. So this is Kf into Am divided by Fm. So here is the modulation index, Kf into Am upon Fm. Yes, one more thing that we are left forget here, when we integrate it, we forget to, you know, one more thing that, come on guys, you didn't tell me this. This is our message signal, so actually I should not write like this. Because this is our message signal AM cos omega mt. Okay, so this is, we are substituting over here. When we substitute AM cos omega mt here, then when we integrate it, it will be AM upon what? If delta phi, yes, 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 exactly. So that time you guys didn't tell me that I missed something in the delta phi itself. So I missed the value of 2 pi kf here. The phase deviation, you can see the phase deviation is the phase value of the FM signal. So you can see the in the expression, this is the expression and the phase is this one. This is the phase. Okay, this is the phase of FM signal. So phase of the modulated signal is 2 pi kf. So 2 pi kf integration mtdt. So this is 2 pi kf integration mtdt. And then when we calculate the maximum value, we have to calculate the maximum value of, yeah, actually that part I missed, and because of that I was not getting the exact one. 2 pi kf and the maximum value of this. So when we substitute this message signal over here, we will get 2 pi kf, and when we integrate it, okay, when we integrate it, we will get am sine omega mt divided by omega m, and this omega m is nothing but your, and its maximum value, So before that we have 2 pi, and this kf divided by omega m can be written as 2 pi fm, and then am sine omega mt. This 2 pi and 2 pi will get cancelled, and now we want to calculate its maximum value, so we will calculate kf am upon fm. Okay, so this is the value of frequency phase deviation, not frequency, phase deviation, maximum phase deviation. Okay, now here also you are getting the same thing, kf am upon fm, which is same as the maximum phase deviation. So this is coming same as the maximum phase deviation. Okay, now one more thing here you can observe, that it depends on, okay, this frequency deviation depends on what? This frequency deviation depends on what? Amplitude of message signal only. Amplitude of message signal only. Okay, amplitude of message signal only, right? So in case of PM, you saw that the maximum phase deviation depends on the amplitude and the frequency of the message signal. But in case of frequency modulation, we are seeing that maximum phase deviation, maximum frequency deviation depends on amplitude of message signal only, not on the frequency. Not on the frequency. Okay. So do you have any doubt in this basic definitions of PM and FM? Okay. Is it clear? So guys, this is it for the today's session. So I think I have already told you the basics of the AM, that is your angle modulation, then frequency modulation and the phase modulation. So the topic that we have covered today, there is a 60 to 70% chance. Yes, there is a 60 to 70% chance that the question will come. Suppose if you face any problem in the angle modulation, then let me know. Do you have any more doubt, Dreamer? Do you have any more doubt in this? And thank you so much, Dreamer. I, try to write very clearly so that every concept is also clear in your mind. I try to write things very clearly so that everything will be there in your mind, very clear picture of that. Okay, so in the angle modulation it is sufficient. If you have any doubt more about angle modulation, then let me know so that I will try to explain that also, Dreamer. Yes, I will send the PDF in the BYJU'S exam prep channel. So this PDF you can take directly. Okay, I will share this PDF. So there are in the link there is a in the description there is a link for the ebook, so you can download an ebook also. So everything is given in the description. You just go in the description and check and see your interest, and accordingly you can go to that particular link. So thank you for watching this session. We will meet tomorrow with the new topic, which is where random variable. So tomorrow we will discuss the concepts of random variable, and what are your doubts, just ask me tomorrow, and you can tell me now also. Dreamer, you can I will not share in my personal channel. You will get the PDF in the official channel of BYJU'S exam prep only. So what are the topics that you want to learn in the random variable? Let me know so that I will come prepare with that, so that I will be preparing the PDF accordingly. What are the topics that you want to revise in the random variables? What are the topics you want to revise in the random variables? Accordingly, I will discuss the topic. I will take the questions also. So if you will tell me, then I will discuss the questions also. Yes, round up tube. That is why I am saying which topic of random variable you want to revise or you want to learn. So accordingly, I will come prepare with the questions also. Okay, so I think I will take that particular call tomorrow. That which topic I have to discuss in the random variable, because right now you guys are not telling exactly about the topic. So I will tell the important topics of the random variable tomorrow according to my experience and according to the past previous year questions. Okay. Thank you. We'll meet tomorrow at the same time 4 p.m. and we'll be discussing very important topic of random variable and also take the 2 to 3 questions of the random variable. Thank you.